in the first hour. And one-sided limits means this. It says the limit as x approaches a from the left. So when it says this, x approaches a, but it's a little minus sign, that means from the left of f of x equals L. You literally say from the left. That means if I have a graph, and here's my coordinate point, if I'm coming in from the left, you have Howard by himself coming in. There's no Harriet involved in this action, only Howard. So you're only coming in from one side. So as I'm tracing in from the left-hand side toward that number from the left. Equals L means that the limiting y value is L as x gets closer and closer to a from the left-hand side. That means we are considering what happens to our function values as we pick x values close to a, yet slightly smaller than a. So if I were at 4, I would be picking 3.99999999999. That's to the left of 4, but smaller than 4, but very close to 4. This one, x approaches a, and the little plus sign means from the right. So that means if I have a graph, now only Harriet's involved. And then she's coming in by herself. You're only coming in from one side. Now that plays a huge role in some of the functions that we're going to be dealing with as we go forward. We will generally look only at one-sided limits when we have either a piecewise function or a function having more than one or more vertical asymptotes. So that's where things are going to be, or a function whose domain is not all real numbers. That's like square root. So if I were to look at the square root of x, look at his graph. Right. I can't come in from the left, but I can come in from the right. The limit from the left doesn't exist, but the limit from the right does. And the limit itself doesn't, because I can't come from the left and the right at the same time. In other words, left, right, Howard, Harriet. Limit as x approaches a is Howard and Harriet. A from the left is Howard, A from the right is Harriet. So for the limit as x approaches a to be equal to L to exist, the limit from the left and the limit from the right have to be the same thing. That means they have to meet. Limit from the left, limit from the right, they have to meet for the limit to exist. That means I've got two going for me. So here we go to the graph. We want to find the limit as x approaches 2 from the left, from the right, and the limit as x approaches 2. So the limit as x approaches 2 from the left of f of x. Now, if I'm coming in from the left, that means here's 2. I'm only coming one side, and I end up right there at that hole, which has a value of what? 4. Remember, I don't get there, but for all intents and purposes, I'm at 3.9, so I might as well call it 4 as a y value. I'm very close to it. And the limit as x approaches 2 from the right, now I'm only coming in from the right-hand side, and where do I end up? 2. So this is a from the right, this is a from the left, which means that the limit as x approaches 2 of f of x what? doesn't exist. That says if I'm coming from the left, I'm here. If I'm coming from the right, I'm there. Do I meet? No. Because these two guys would have to be the same. Now on this one, doing the same thing, the limit as x approaches 2 from the left. Now I'm coming in from the left, where do I end up? At 2. And the limit as x approaches 2 from the right, where do I end up? 2. So this is 2 from the right. This is 2 from the left. So I can say that the limit as x approaches 2 is what? 2. And it says if I come in from the right, I end up here. If I come in from the left, I end up there. And because it's a whole, for all intents and purposes, I meet. Do I meet? Do I not meet?